Hello everyone, George here, and we're back again in my implementation of Toejam Earl and VR concept piece. Now, we're getting kind of far ahead. We've got several different systems in place. Gameplay is starting to come into something, but we're still missing some critical components. One, everything's still gray, which is kind of annoying me. I kind of want to start moving away from that. But two is that we don't have a way of winning. Right now we have a way of resetting the game, which is when you fall off the side. We don't really have a way of losing yet, and we don't really have a way of getting to the next area. So the next area would be taking you, well, there's two ways. One is getting your ship piece, so that's part of the win. And then the next thing is getting into the elevator. So what I might do is make it so that the elevator is inaccessible until you get the ship piece on this level. Yes, that's not convention for Toejam Earl, but once again, it's a one-level concept piece. Therefore, better to force you to get to the ship piece than have you just go straight to the elevator and get out without needing to do anything specifically. And that being said, when we get to the ship piece, what's actually going to happen? Do we click on it, grab it, and then press a button? All good questions that I don't have the necessary answer for. But why don't we go ahead and make some of this stuff actually happen? So the easiest thing for us to do is to not have it be clicked at all, but instead just touch it, and then the item is yours. So we can just go to our character class. Let's go over here to character, our script, and we can simply add to this. We could make a ship piece manager if we wanted to, but once again, it's really not necessary because we don't have enough going on in this game. So we can just do bool ship piece collected. False. Really, we just need to set that equal to true when we actually get the ship piece. So what we can do is make maybe a public method that does that for us. Now, who's going to tell us the ship piece has been collected? That's going to be up to either the ship piece or it's going to be up to the hands that we have attached to our body. So we have our left hand and our right hand script, and we have, oh, okay, it looks like we don't have our wings or anything associated with stuff yet. So if we come over here, we've got Earl hand and Earl wing, which we don't have yet. So why don't we go ahead and do Toejam hand and then Toejam wing. We don't have Earls, so just gonna have to wait on the other ones. Toejam L, Toejam wing L. Okay, great. Okay, so the hand is what's going to end up touching this object. So when we do that, that's going to be an on collide enter. So we have hand L, we have a rigid body on it. It's kinematic, so it's being controlled. It's continuous dynamic. It's got a sphere collider, which is a trigger. So when we move our hand over that object, something should happen. We've got this object here, which is our left megawatt speaker. We're going to need to add a collider to that. So we'll do a box collider on that. We'll say that's triggerable as well. And we're going to want to change the type of object that this is. We're going to add to this a new one and call this ship piece. Good. And now what we're going to do is inside of our hands, our left hand and our right hand, we're going to want to do an intersection test. So let's see here. So right hand over here does not have an on collision enter. So we need to add that. So we'll do that really fast. So void on trigger enter. We figure out what we collided with, and that's going to end up being this ship piece here, most likely. We're going to check to see what the tag is. So if other dot compare tag, and then that's going to end up being a ship piece. Then we're going to collect that ship piece. So let's grab this, and let's grab this whole function right here really fast, and also paste it over here in hand L. Now that we've collected the ship piece, or we've identified the ship piece, we're going to want to do two things. We're going to want to remove the ship piece from game and set bool to true that we have it. Okay, so the easiest way to do this is maybe making a script just for the ship piece. So let's go to C# script and do ship piece. And there's our ship piece, and then all we need is a public method. So we'll do public void collected. In which case, all we need to do is do this dot game object, and then I guess we can just destroy it, really. Destroy this dot game object. Now, other things can happen as well. We can add graphics and swirls and particle effects, but for right now, collected is just going to do that little tiny bit of work for us. And under hand R and hand L, we're going to want to do other.gameObject dot get component, and that's going to be ship piece. And then if it does have that component, which it should, but you never know, let's do this. Ship piece temp is equal to that. If temp does not equal null, then we are going to do temp dot collected, and then we need to set the bool true to the object. Now that we can do in the ship piece itself. So what we can do is grab our character, and there should only be one. So in start, or we can do a character, and then in void start, we can do a game object find game object, find object of type, and that's going to be character. And then character is going to get stored here. And then what we can do is in here we can do character dot and what do we call it again? Ship piece collected dot ship piece collected equal to true. And yes, we need to change the accessibility of this to public if we want to do it this way, which is fine for right now. I don't see a reason we can't. And we're going to copy it, and this is going to happen at the ship pieces location. What we should probably do is if character.ship not character.ship piece collected, then we'll do this. Just in case we get a double access for some reason. We'll see what happens in the future. But anyway, let's go back over to hand R and copy this functionality and paste it into the other hand. So they both do the same thing. And yeah, okay. I think we're doing well here. So now that allows us to pick this up. Now the elevator is going to need to be scripted as well. So if we zoom in on the elevator, we're going to want to create an animation that scales this part in like that. So we're going to need a script. So why don't we go ahead and create an elevator script. Elevator script. We're going to want an area in the front of the elevator that's going to have a collider on it. So we have the elevator itself. We can go in here, we can add a box collider, in which case it's the wrong size. So let's go to the body, add a box collider, and then let's go ahead and copy the components, remove the component, go to the elevator itself, and paste the component values. And that's going halfway through the floor. So let's go ahead and move this up to like there. So that's our collider for the outside of the object. We're also going to want another collider that goes on the outside of this thing. So we're going to move this in the Z direction to the front, something like right here. Increase the Y size, and this is where you get close to the elevator and you're trying to get inside of it. Something like that. And we're going to move this a little bit further out. And when you access that collider, it's going to try to open. Basically, any of the colliders are going to try to open it for you. Okay, so this one's a trigger. This one is just a simple collider. I don't think I need to worry about rigid bodies just yet. What we do need a script that's going to react to what's happening here. And if you touch on any of those colliders, the script is going to try to open the doors. So let's go back to elevator script, and we're going to want a coroutine to handle animating that door open. So in the elevator script, we're going to want two transforms. Just transform door left, and then transform door right. We can do serialized field. Okay. So we got both of those doors down, and then we're going to want a, let's see, how we want to do this. So if you get close to it, it's going to start animating if you get far away from it. So we're going to need on trigger enter, and then we're also going to need private void on trigger close, on trigger exit. And all these are going to do is tell us whether or not we're close or not. And then that's going to cause whatever our animation script is to change its mode. It's going to change the values it's trying to get close to. So we need to come over here and first add our elevator script to the object. Then let's add our left door and our right door to the object. And in addition to that, then let's scale this to where it's acceptable. And that's a 0.1836 or 0.18. Okay. So 0.18. So float 0.18 f door open scale is equal to that, and then float door closed scale is going to be equal to 1.0 float. And so when we trigger it, this is going to start a coroutine that's going to have us either trying to open the door or close the door until we exit, until basically it finishes doing whatever it's supposed to be doing. So in which case we're going to need a bool value, bool open door is equal to false. And in which case we're going to want open door is equal to true, and then on exit, open is equal to false. And we're going to use those values in our coroutine to check to see what way we're supposed to be doing this, whether we're supposed to be opening it or closing it. So we'll do an I enumerator, and then we'll call this door control. Why not? Let's call it door control. Door control is going to get called when you enter into it, if it hasn't already been called. So what do I mean by that is we're going to need a coroutine, and call this door control is equal to false. And then if you enter into this thing, and that's not true, that's no. If you enter into this thing, then we're going to do a start coroutine. If door control does not equal null, or does equal null, then we're going to do this. Right, we're going to start this coroutine right here. And this coroutine is what's going to be important. It's going to continually animate the door opening or closing based upon whatever the value for open door happens to be. So let's see, we need to do, we're going to have to do a yield at some point, obviously, to make this work. But we also need a loop, and that loop is going to be going until our current value is equal to either door open or door, well, it's going to continue to do it until our current value is equal to 1.0 or a closed door, because the function will just keep running. Yeah, okay, so we'll do it that way. So if current value is equal to current value is equal to door close scale, which is no, let's do it, is equal to 0.0. So float current value, and then we want to, while current value, what do we want? We want open door. While open door is true, then we're going to do this thing. Otherwise, we'll have to do a check. If current value is greater than 0.0f, then we're going to want to do a while not door open. See, okay, I'm not liking how I'm doing this already. I'm feeling like this isn't the right way to do it. And that I should have two different methods that are going to be assisting me on this rather than trying to do it all inside of one. I think I need a massive while loop that's just checking to see whether or not we're in range or out of range. So let's make a different bool value called bool in range is equal to false, just to make things a little bit clearer in my head. So when we enter this, in range is going to be equal to true. And when we exit it, in range is going to be equal to false. The first thing we're going to do is while in range. Then we're going to open the door. And then otherwise, if we're not in range, we're out of that loop. In which case, while not in range and current value is greater than 0.0 float, that means we're interpolating to close it at this point. We need to start closing the door. And then inside of each of these is going to be a yield return null. Okay, I think that makes sense. Now what happens when you come in range though of the object and this is still going? It's not going to start opening the door back up because I don't have this going back up to here. I almost need another loop outside of these loops, which is why I think I should be storing current value outside of the door control. And then I should do two of these, open door and close door. And this can go. So while we're in range and current value is less than 1.0f. So what we're going to want to do is change how this functions. So on trigger enter, this happens if door control, which we're going to change its name to door animation. Now, how do I do comparisons with coroutines? Is that something I can actually do? Unity, how to test what coroutine is running. That didn't help me. So rather than use enumerators, why don't we just use voids and get rid of the while loop? And do if loops instead, and then just have these as part of the update loop if I'm having issues between the two. And then all I want to do is current value plus equals time.delta time. And then there should be a rate, so an open rate. So let's make a float open speed is equal to 1.0f for now, because I don't know what the right speed is going to be. And then that should be times time.delta time. That's current value. And then let's see, current value starts at what, 0? And then I want the current value to be going subtracted from whatever it should be on the other one. And then we just need to lerp between them, right? So if we just do a vector 3 lerp between two vectors, and that's going to be between door open scale and door closed scale. And then we need to use current value between those two. So this is going to go from opening to closed. In which case, what I really want this to be is from closed to opening. So let's and we need to change these into vector 3s. And this is going to be a new vector 3. And these are in the, what direction are they? I believe it's the X direction. So X, 1.0F, 1.0F. And then we need to do the same thing for this. Okay, so now we've got our door open and our door close. Not worried about this stuff yet. We'll get to that soon. I'm worried about implementing these methods in here and making them work properly. So in range is what's going to be doing this kind of stuff. We can get rid of this coroutine right here. Okay, we're going to do this in the update method. Basically, we're going to do if in range, do one thing, else do other thing, which is going to be open. If in range, we're going to open door. Otherwise, we're going to do close door. And it's one object in the world that's getting an update method dealt to it that we're not checking to see whether you're in the proximity of. So I'm not going to freak out. That's something we can come back and change later if optimization is necessary. Okay, so we've got open door and closed door. So this value is going to be added and get bigger, and it's going to interpolate between these two vectors here. And then we need to make our doors update based upon that. Now, let's do a quick sanity check here, and it looks like, unfortunately, that our pivots are in the same direction, which means one of these is going to be negative. Oh wait, maybe not. Hold on a second. No, they're not. Okay, great. So they're both in the same direction. We're fine there. So which means we can apply this to both of our doors. So our doors are just transforms. So we can do dot local scale is equal to vector 3 temp is equal to this, and the door r dot local scale is equal to temp. Great. Now we can copy pretty much this verbatim and bring this into the next one. The only difference is going to be, well, you can see right here, we're subtracting what it's going to be, and because we're subtracting it, actually, I think we can keep this the same way, because this current value is going to be now progressing towards the closed state. So we shouldn't need to change any other code. Now we just need to go in our update method here and make sure everything's working there. So in range, and then that happens here. And then we either open the door or close the door based upon that. So that being said, there's no way it's going to work, but let's give it a shot and see what happens. So we have our elevator door itself, and let's grab and hit run. Let's grab our body. Ooh, that's loud. Oh my gosh. Let me turn that way down. There we go. Okay. So let's grab our body and move it up to the right place. So where's body? There it is. Hit the W key and slowly move it up. Whoop. Pop. Gotta be careful on those ramps. It really likes to fall through, doesn't it? So we should have hit the collider, right? There we go, it opened. Now let's see if it closes. And it closes. And it works properly, check that out. Now the problem is the box collider won't let us into the actual elevator, but that's fine. It works. Great. So let's stop this. And we're at the 30-minute mark, so it's probably a good chance for me to take a quick break do something different maybe, and we'll jump back into this at some point. And yeah, that's good progress for us. We actually have the end game kind of result going on. Oh, you know what we didn't check is selecting the megawatt speaker. Now the megawatt speaker does not have the megawatt. Let's see, tag needs to be ship piece. Let's try this again really fast. And grab the body and be very careful on the slopes. Move that up a little bit, there we go. And let's see. Okay, it did not grab the object and it did not delete the object. And that's because the ship piece code is not on the ship piece. So let's go back to the ship piece and add the ship piece to it. And hit run. Now, if we're good, we can do this a little bit faster this time. So let's see if we can grab it with our arms this time. Yes, okay, so the ship piece can now be selected. Now, one thing you'll notice is not working is the doors are still opening even though we do or do not have the ship piece. So that's something we want to amend really quick. So elevator script is going to need access to the character object. So once again, we're going to want to do character is equal to null, and then start. Let's do character is equal to find object of type, and then that's going to be character, and then character is going to need to be tested inside of here. So if in range and character dot ship piece collected. Do this, otherwise close the door. Yes. Okay, perfect. And with that, now we're truly done with this video. So we've implemented just the very basics of what's necessary. I think in the following video, we're going to dive in and actually add some color to this world because it's a concept piece, but at the same time, when you show a concept piece to a target audience, they're not going to understand things. They're not going to understand why it isn't colorful, why it doesn't have the graphics necessary. So we're going to need to spend a little bit of time diving into Substance Painter, just throwing down some basic grass and some rock textures on things, and then colorizing other parts, maybe adding the flashing lights to the ship piece location so that it reminds us a little bit more of that original game and gets us a little bit more excited about what we're actually seeing. All right, everyone, I'll see you next time. So long and goodbye. Hi, everyone. I hope you enjoyed this video. If you want to see more, remember to subscribe and hit the bell if you want notifications about new videos I upload. And if you'd like to help even more, consider becoming a patron on my Patreon account. Links, as always, are in the description. See you next time. So long, goodbye.